All right, so let's go on, and we can see it at the end. Okay, so SD-WAN from the syllabus point of view, it's a encore topic, and the topic which is being listed under 1.4. Okay, SD-WAN control and data plane elements, the traditional WAN and the SD-WAN solution. So a basic thing which is being asked. Okay, but if you wanna do a dedicated SD-WAN concentration CCNP paper, then yes, you can go and pursue that. Okay, so if you go with CCNP Enterprise, there is a dedicated paper for SD-WAN. Okay, like how we covered NRC, which is one of the concentration paper. So you can skip NRC and you can go to SD-WAN if you are interested with SD-WAN. Okay, but the reason why we took this NRC is because the main target here is for CCI number, right? So if you want CCI number, you need to be good with your advanced routing and switching. So where is your SD-WAN? SD-WAN is here. Okay, SD-WAN 300. So the topic for SD-WAN 300 is in depth. Okay, so these are the different topics. We have 6 chapters. Okay, so basically the chapters or the 6 chapters talk about the architectures and the components. Okay, the SD-WAN components, the orchestration plane, the management plane, control plane, the data planes. We have then the W or the WAN edge platforms like V edges, C edges. Okay, so let me tell you, the SD-WAN, the Cisco SD-WAN, which also we call as Viptela. So this was a third party company, or this was a complete different organization which Cisco purchased it. Okay, and then they collabed it and they started getting called as uh, something like SD-WAN for Cisco, or Cisco's Viptela's SD-WAN, or these kind of devices. If you see, they are labeled with V. Okay, V stands for Viptela and C stands for Cisco. So that's why you see the controllers which are still reflecting V, because they were first initially developed by Viptela. Cisco is making its move to convert all this V into C, like C bond, C manage, C smart, but it will take some time. Okay, because it wanna take out that Viptela thing and wanna put its label. SD-WAN can be deployed in multiple deployment model: on premises, cloud, hypervisors. Okay, so this is about that. So you have this, as I told you, the VMware, the cloud, all those things. Regarding the certificates and whitelisting, okay, so how this SD-WAN basically works is, let's say if a customer XYZ, he wanna buy this SD-WAN. Okay, so it doesn't mean that he will not buy the internet and MPLS. He still have to buy MPLS and internet. Okay, so let's say I have customer XYZ and he has multiple branches. So let's say this is his headquarter, this is branch 1, he have branch 2. The legacy option would be that he is having MPLS connection and he just connected all his different site. Or let's say he has a campus network coming up, and these campus network wanna connect with the different branch location. So basically he can go with MPLS, but MPLS is a expensive technology. He cannot afford for 10 people sitting in the campus. So what he will do is he will make use of the internet and he will build the VPN tunnels. Okay, so he'll build the VPN tunnel which is still more economical in range. These are the underlay. I can call it as underlay transport. Now, where is SD-WAN coming? SD-WAN is coming on the top of this underlay transports. Okay, so we have this SD-WAN technology which will be on the top of the MPLS and internet. But what is the benefit of SD-WAN then? Okay, if SD-WAN is not providing me the reliable communication, it's neither MPLS, it's neither internet, then why do people need SD-WAN? The reason is the features which MPLS or internet cannot provide us. So basically that can be achievable via SD-WAN. Say for example, application awareness routing. That means in the back end, if I have some servers for critical applications, I have a different server for WhatsApp. Let's say I have a different server for some payroll applications. Now these are different applications. If it was MPLS or internet, it would have given equal privilege to all these applications, right? Yes, you had option of making use of QoS, you had options of firewalls to enable, disable, but that is from network point of view. Once they are on the internet or once they are on the MPLS, then there was no option of giving the privilege on the application. Whereas in the SD-WAN, since it is sitting on the top of these MPLS and internet, we can set the parameters. We can say that it is a payroll server. I'm gonna give it more privilege. Okay, my path should be such a way, or I will select that path to be the best path, which is free at that moment of time. Because see, when I have MPLS, when I have internet both with me, might be my MPLS was slow at that particular time, right? I still have internet. So I can say that the payroll server, if it is stuck at MPLS, I can make use of internet. Now that was not possible if I don't make use of SD-WAN technology. My still packets will be preferring MPLS. Until MPLS is completely down, there will be no switch over happening. There is no failover happening. Okay. But SD-WAN is more intelligent. It's gonna see the live traffic that is happening in this transport channel. If MPLS is down, not just down, if there is a jitter, there is a delay, there is a bandwidth issue, there is load issue, SD-WAN will prefer the internet path. Okay. Why only MPLS and internet? I can also add multiple other low cost solutions. Say for example 4G, the 4G, the normal mobile which we use. Now you think that we are making use of 4G, which we are also using in the mobile smartphone, which is the cheapest option of the internet transport. If I have two campus, why can't I make use of that 4G technology to connect these two sites? Okay, so that's possible with the help of SD-WAN. But yes, if you don't have SD-WAN, you might be thinking, why don't I connect the 4G technology irrespective of SD-WAN? But the issue would be, let's say there happens your application, multiple application, and they are gonna consider the equal privileges. So what happens is your actual data or the actual server, which is mission critical server, the packets will be in the queuing. Okay, they will be stuck in the queue. Okay, so those things we can achieve from SD-WAN. I can say that this is very important traffic, the rest of the traffic can wait, but I need to send this traffic. Okay, so SD-WAN is acting as an overlay and your other technology act as underlay. It's gonna help you as a application awareness routing. It is gonna provide you internet breakout. It is gonna be the simplest option to deploy. Okay, you can easily deploy the whole concept. And the main thing, once again here is that you are gonna segment the planes. Okay, in the case of MPLS or internet or the normal legacy method, these routers basically they will have the three planes: the control plane, the management plane, and the data plane. If the control plane for some reason is exhausted or overheaded with the number of packet, the entire site will be impacted. Okay, but in the case of SD-WAN, SD-WAN is pulling out that control plane to itself. Now SD-WAN act as the control plane or the decision maker, and these boxes, the devices, the real devices which are kept on the enterprise, they just act as a data forwarding. Okay, the control plane will be making the decision whom to send, what to send, which application to be given the highest priority, which transport layer to be used, whether MPLS, 4G, LT, whatever. It's all decided with the SD-WAN which is on the top, and the real devices kept in the core will be only doing the forwarding, the data forwarding. Okay, and this technology works on the certificate and whitelisting. So whatever I told you, SD-WAN, let's say they are on a central basis. Okay, and you have your headquarter, the branches, campus, and all. So you have the devices kept. Okay, so the controllers will be kept here. Now these devices have to form a peer relation with the controller, and now this will happen when they are properly configured with certificates, they are being whitelisted, then only these devices, the data plane devices, will form a successful relation with the controllers. Okay, if the certificate is not matching, if the whitelisting is not being taken care, they will not form a pair. Why do we do this? Is to avoid the to avoid some kind of attack. So let's say if someone comes up with his data center and he wants to use SD-WAN, there is possibility that these two devices he can just pair with this controller or this SD-WAN, and he can make use of someone else package, right? So we need to have some certificates installed here, some whitelisting mechanism installed here, which consist of certain data, say for example the site ID, the serial key of these devices. So only those serial devices will be authenticated. Okay, so only these boxes will be authenticated, so anyone else cannot just form a peer relation and form a SD-WAN, or can use a SD-WAN, someone else SD-WAN. Okay, so it happens with the certificate and the whitelisting. So whichever is a right end devices can only form the successful uh, peers with the SD-WANs. Okay, the router deployments, which talks about onboarding, orchestration, the zero touch provisioning, plug and play. Okay, so we have multiple things here to simplify the option of the end devices forming whitelisting or certificate mapping with respective to the controllers. Okay, so we have ZTP and plug and play. So Viptela was using ZTP, and Cisco is making use of PNP. Okay, so these are all the mechanism to simplify the option of SD-WAN and the end devices. These are the protocols, the TLOCs, OMP. OMP is Overlay Management Protocol, which is a protocol for SD-WAN. Okay, I can say that they are very equivalent to the BGP protocol of your enterprise level. Okay, so we know that in the case of BGP there are three packets or the three neighbors. Okay, the three neighbor tables. In the case of OMP they have four. So that's the only change between the two, BGP and OMP. The rest are very similar, like you form the manual neighborship, You will define the certain things like AS values in the case of BGP, whereas in the case of OMP you will define site IDs. Okay, so basically I can say OMP is SD-WAN's protocol, whereas BGP was in the case of the enterprise protocol. Okay, so this defines about policies, the service and QoS, the management, and a pretty simple topic for CCNP guys. Okay, but we are not gonna cover this in this particular batch because this batch was made up for NCore and NRC. So we got some requests from students where they wanted to learn SD-WAN from us. So we have uh, a dedicated batch coming up for SD-WAN itself, only SD-WAN. We are not going to cover neither NCore, neither NRC, only SD-WAN. We are planning for like a 2 weeks of boot camp or a 2 weeks of course content where we are going to discuss this whole thing. The labs are created on our server, so the students will get the server access where they can practice each and every component and each and every concept of SD-WAN. Okay, so you can take it from certification point of view if in case you wanna certify, or if you have a project coming of coming for SD-WAN, you wanna practice or you wanna learn a new technology, then yes, you can enroll it. Okay, so basically my plan is to make uh, to make a basic batch first, which will cover the basic SD-WAN. Okay, where we will discuss about the basic controllers, the components, the policies, the templates, and then we will have something for advanced SD-WAN also, which will be more like your CCNP plus CCI point of view. Because uh, if you have ever seen the CCI lab for the 2020 syllabus, they are not just this. Okay, sorry, this, they are much more than this topic. Okay, so the CCI lab has more number of topic for SD-WAN. Okay, so that's a advanced thing. So if I show you the Cisco enterprise for CCI, the SD-WAN topics are pretty much different. Okay, so this SD-WAN 300 was a basic topic, or I can say it is an intermediate to advanced topic. So if you go to the lab exam, CCI lab, so you have a topic for software defined infrastructure. So you have these topics which are for your CCI lab. Okay, I can say that it's almost same as your CCNP concentration paper, which is SD WAN 300. Okay, so basically SD-WAN as of now is being divided into three things. One is the SD-WAN basics, we have SD-WAN 300, and we have SD-WAN for CCI. Okay, so this should be something for intermediate to advanced guys, and this is for the basic guys. Okay, well, so that was from the syllabus point of view. Now those who never seen the SD-WAN topic, so you know where to go and where to find it. Okay, so let me open my presentation for SD-WAN. Let me go through few slides. Okay, SD-WAN. So first we are gonna see the traditional WAN. Okay, so as we all know, we have the customer end and we have the provider end. So in the provider end, we have a main link as a MPLS, and we have always the backup link as a internet, or we can keep a dedicated link like 4G or LTE or the VPNs. Okay, so basically this is how we been seeing the internet or a enterprise to enterprise connection. Okay, the traditional WAN connection. And from the plane points of view, if you ever get to see these planes, all the three planes are on the single router. Uh, you have your data plane, you have your control plane. Okay, so this is the management plane, control plane, and data plane. Okay, so one router which has all the three planes within it. Now the problem with this kind of solution, or this kind of a standalone point for three planes, are that if the control plane for some reason is getting exhausted, the CPU load is 100%, the forwarding gets delayed. Okay, and if the devices which are kept in the core layer of your enterprise, if they are being lagging, the end devices or the application, they will start breaking. Okay, they will see the slowness. Your monitoring tool might be flooded with lot of red alerts saying that the server is down, or the polling is not happening. That is all because your control plane is exhausted. There's no way control plane can tell whom to forward. Okay, so this is the traditional WAN method. Now we wanted a solution where we can optimize the WAN network or the WAN architectures. Okay, what are the challenges with this legacy methods? Are there is insufficient bandwidth. If you are making use of MPLS, okay, for some reason if MPLS is getting exhausted, you will still be using MPLS only. Okay, until MPLS is completely down, you won't switch over to the next link. The next link act as the secondary link, which is again a smaller bandwidth link itself. If a MPLS itself cannot handle that, there is no way the secondary link can handle that, right? So it's a part of insufficient bandwidth. Limited app awareness. You have n number of application in the backend. They will still make use of the same path for every TCP connection. There's no awareness given to these apps that you take this path, you take that path, you take this path. Might be this path is not utilized every time. Might be you are a least bothered application. You take the 4G path. Don't go via MPLS. Let's give MPLS for some other application. So there is no awareness created in the traditional WAN. Okay. Security challenges. All the planes in one single router. You do not know who can hack through or who can analyze your packet. Okay, there's no way you can secure this kind of MPLS or internet, because they are all over on the shared medium. Okay, as we all know, MPLS is a costly technology, so that's why when we have branch to branch or a small office to office, we always go with the IPsec tunnels, because they are easy to configure and they are not very expensive. Okay, no cloud app readiness. It's all on premises, right? Your all MPLS, your internet so far, they are all on premises, and we know that we are now moving towards cloud. We want our devices on cloud. I pay for something, I get the services. If I want to expand something, I'm gonna pay the top up amount and get the service. I wanna reduce my head count of my engineers. I wanna reduce my devices. I don't have to worry about those physical devices, selling it to someone, all those things. I say that cloud party, that I don't want this service cut down by 50% and I'm all good. Okay, complex operation. So basically you have to make use of those CLI methods every time to change the routing, to optimize. It's a complicated process, right? So these are the challenges that you see in the case of traditional uh, connection, or the traditional WAN connections. Okay. So how is this SD-WAN or the SDN going to help us? So basically they are gonna be reducing the deployment time, because they are all uh, plug and play. Okay, you just buy the services, you are ready to use them. This the control plane or the management plane or the data plane are being segmented. Okay, so the control plane will be taken care by the overlay or the SD-WAN controllers, and the forwarding will be happening in the underlay devices. Complexity, so these are all graphical, there is no CLI. Okay, you can just ignore that. There's no need to pay a lot of money for MPLS to have the connection. If you are having the 4G LTE or the internet, you can still make use of the SD-WAN to take one of the transport channel. So that's what it says, less cost, because SD-WAN don't demand MPLS all the time. If you don't have MPLS, you still have 4G or LT, you can still make use of SD-WAN on top of them. It is easy integration, zero touch provision, plug and play. Okay, you just activate this portal. These are actually the portals, online portal. Okay, so let's say you go to www.cisco.com. You have to log in with your registered email ID or the contract ID and the password. Over there you will see the dashboard where where you have to map your all devices like V edges. Okay, and you will try to integrate with the vManage controllers. Okay, so it is easy integration. You don't have to open CLI, you don't have to enter some installation or activation of these devices. They are like plug and play kind of things. Okay, what is software defined networking? Now basically, let me tell you the SDN umbrellas. Okay, so let's say SDN, software defined network. Okay, so this act as a umbrella for three of the software defined technologies. Okay, so we have SD access, we have SD WAN, and we have ACI. Okay, so all three act act as a components under SD-WAN. As SD-WAN is that wide range or the umbrella. Okay, where do we use SD access? We use SD access in the case of LAN. Okay, in the case of LAN, the distribution and the access layer, those devices needs a overlay, a software overlay. Okay, so the distribution and access switches, they are just acting as a forwarding data plane. The overlay, the SD access technology, will be controlling the control planes. Okay, and we use the protocols like Lisp, VXLAN to integrate the underlay with overlay. Okay, what is SD-WAN? SD-WAN is in the case of WAN layer, or I can say the core layer. Okay, this is happening in the LAN side, this is happening in the WAN side. On the core technology, the protocols like OMP we see here. We see the DTLS tunnels, TLS tunnels, we see the IPsec tunnels, we see the GRE tunnels. Okay, inside SD-WAN between the different controller, the V edges, and ACI is under the data center component. Okay, so each technology depending upon its usage. So we have this over LAN, distribution access layer. the core layer, and this in the data center. Now coming towards the heart of this technologies, okay. So in the case of SD access, we make use of DNAC, DNA Center. Even in the case of ACI, we have the same controller called as DNAC. In the case of SD-WAN, we have controller called as vManage. Okay. So DNAC is a physical box. They don't come in a on they don't come as a cloud, or they do not come as a VM or a hypervisor version. They are always a physical box. It's the vManage which can be seen as a hardware, on-premise hardware. We can take a package from AWS guys or GCP people, okay, or we can place it in a VM, okay. So we can put this under the VM workstation and we can spin up, okay. So basically vManage is one that particular controller out of three which act as a cloud, or we can use it as a virtualization. So you have options. So that's why in the lab we can construct the lab for SD-WAN, but for ACI and SD-WAN we need the real devices for practicing. Okay. So what is SD-WAN? SD-WAN is a approach to abstract the control plane. Okay. So you're basically taking out the control plane from those underlay devices. Okay. So if I have devices, these devices act as underlay, and they're gonna just do the data forwarding. So you have your controllers here, okay, and you have your control plane here, and in between them there is a API, application programming interfaces. So this API, we gonna call it as a southbound API. This we gonna call it as northbound API, okay. And these APIs, they communicate over on REST API. REST API internally have the HTTP communication layers, okay. So that is why when we talk about APIs, REST API, HTTP, we make use of the words like HTTP response code, where we see the code like 400, 300, 200, right? So that's the job of API. What does API do is, API communicate over on HTTP protocol. They don't talk on SSH or Telnet now, okay. So this control plane to the controllers and the end devices, they communicate via APIs, the programming interfaces, application programming interfaces, okay. So this is your GUI interface of vManage or the DNAC. So basically here your real devices will be kept, like your DNAC, or here in the case of SD-WAN we have the vManage virtualization, and over in the control plane we have the GUI dashboards, okay. And the real devices, like in the case of SD access, your distribution devices will be kept here, which has only data forwarding job, okay. The rest will be controlled from the control plane. So it's about three plane separation. You have management plane, the control plane act as a programmable, okay. Okay, so regarding the SD, the Cisco DNA Center, okay, as I told you, SD access is gonna make use of DNAC, and ACI is also gonna make use of APIC controller, okay. But in return, APIC is also making use of DNA, okay. So in the case of SD-WAN, we have this vManage controller. So vManage can be placed as a cloud on premises and the virtualization, okay. But yes, Cisco's intention is to make it universal, and they want the Cisco DNAC to be the universal controller for SD access, SD-WAN, and ACI, because customers are not happy having multiple controllers for each and every technology, right? If they can have one controller, one dashboard, which can take control of WAN, uh, the the SD access devices or the distribution devices, as well as the data centers, then they are more than happy to take those or purchase those technology, right? So yes, there's something which might come in the future, but there's no such rumors anywhere, or there is no such uh, official document about this kind of approach. But yes, Cisco is planning to have a universal controller, because from the customers feedback which they receive every for every technology. So you might be knowing that Cisco's SD-WAN is not a top one product as of now. Okay, there are other product from other product for SD-WAN, like Silver Peak, FortiGate, which are better than the Cisco's one. But Cisco is giving a tough competition. It's trying to come up. Okay, so basically, it will check for the feedback. It will try to take out the complaints and get a better uh, outcomes, right? So these are some complaints where the customer is having three controllers for three different technology. Okay, so these are some things where the Cisco will work on to bring this technology as number one. Okay, so how does the SD-WAN or a uh, how does SD-WAN basically works? Okay, so we have the flexible connectivity option in the case of SD-WAN. Okay, so see, if you see here, we have MPLS, 3G, 4G LT, and internet. So we can just take any path, whichever path is free. Okay, there is no latency. We can take that path. We don't need to define any time slot. We don't define certain things here. If my SD-WAN overlay sense that if this path is free, let's take this packet over on this, then that's fine. It's gonna make use of those part. Okay, they're flexible, they're low cost, is also an option here. Application aware routing. So the benefit of SD-WAN is, as I told you, if there is an applications, okay, so let's say we have couple of applications here. Might be we have WhatsApp, we have the payroll servers, we have monitoring tools. Okay, we can set some policies that the monitoring tool which are more sensitive will take always the MPLS path, because that's gonna be 1 gigabit per second. Okay, the payroll, which is the second important for me, they will be taking the 500 MB broadband transport channel. Okay, and the WhatsApp, which is the least important, let them take the 4G or LT. So now what happens is, for any reason, WhatsApp traffic will never go via MPLS or broadband. They are meant to go via 4G. Now that cannot be achievable in the case of the legacy or the traditional WAN. But in the case of SD-WAN, it is very simple for us to put the application aware routing. Secure segmentation. Okay. Now, to those users who were depending upon these VPNs, okay, for secure transport channel, you don't have to worry. Your SD-WAN is still gonna support the VPNs like IPsec, okay, the different transport channel. So basically, it is end-to-end segmentation. So you can see here the internet connections. You have your MPLS connections. You have your 4G LT connections. Okay, the local internet breakout. That means, let's say, as a home users, Okay, why should I always make use of SD-WAN for my YouTube streaming or something? Okay, SD-WAN gives an option of internet breakout. Now this breakout is something where the traffic for YouTube or WhatsApp or anything apart from non-production can go via the user's own internet. Now this will not be taken inside the SD-WAN configuration or within the SD-WAN flow. Okay. Now this type of things are called as internet breakout, where the traffic can come out and go via your own internet, because you don't want to send it over SD-WAN for YouTube streaming, or if you're watching some movies, you don't want to happen that. Okay. And the secure cloud gateway. So SD-WAN is gonna provide you the security end-to-end segmentation. If you want to go with IPsec, you can still make use of IPsec, and on top of that you can place the SD-WAN. You can also have local internet breakout. Might be there are so many users who watches YouTube. With one you will not feel much difference, but when there are like 100 users who are watching YouTube, who are watching movies, if that traffic leads to SD-WAN, SD-WAN will make the calculation. It will see that these users should go via 4G or they must go via MPLS. But why you wanna even put some kind of overhead on the SD-WAN? You can straight away give the internet breakout. They can go via the normal internet package. They don't have to go via SD-WAN decisions. Okay. Service based engineering. Okay, so let's say as a user I wanna access some servers, app server. Okay, now you might be wondering how SD-WAN is gonna control whom to allow the servers, or which user can allow this server and which user can allow some service out of that server, because this server might be loading or hosting applications for TCP 80, or might be TCP 443, or some different server applications, or services. We call these as services: 80, 443, 25, 23. So multiple services are loaded on these servers, right? How do we give the security now? Now we can also make use of SD-WAN's service based traffic engineering. So we can have the firewalls where we can put the limitation on which port to allow, whom to deny. Okay, so everything is possible in SD-WAN. So you don't have to worry that you cannot be able to do this, or you may not be able to do some other things which you were doing it. Okay, so basically it's gonna support everything. Cloud ready WAN, as I told you, SD-WAN lets you more number of deployment model. Okay, so what are the deployment models? So we can have it on premises, we can have it on the cloud. Okay, I can go and purchase it from AWS, GCP, Azure, or I can also have it under my virtualization if I have a bare metal servers with some hard disk. Okay, so basically it needs lot of vCPUs, it needs lot of RAM, and it needs lot of CPUs. Okay, it's not gonna work on your laptop like i7 laptop with 8 GB and all. Okay, one single controller will need 16 GB of RAM. So we can virtualize this if we have the bare metal servers with 32 CPUs, vCPUs, if 128 GBs of RAM. So if you have such servers, we can put the SD-WAN lab and we can spin up. Okay, the normal laptop is not possible. And for customer point of view, they can go with on premises. On premises is like more security, more control in the customer's hand. They can increase the number of devices, or they can put some, add on some RAM. But whereas in the cloud, it's little expensive, and there is no flexibility. Okay, whatever the vendor are supporting the package, you have to buy it. You cannot say them increase the RAM by 10 GB or 100 GB. You cannot do that. So if they are offering something, you can use it, but you cannot be more flexible. Virtualization is like on your VXI, EXI servers or workstations. Okay, so yes, it's a cloud ready. If you wanna use it tomorrow, you can go ahead, you can pay today, and you can get the service, and you can take it. Okay, how is it gonna be simplifying the entire thing? So we get this kind of the management interfaces. Okay, which is gonna give me every detail about my different controllers, which controller is down, which controller is up, what are the number of end devices I have here, uh, what kind of health view I have, what kind of the VH summary that I have. Okay, the different logs. So basically I can also see from application point of view. So you can see here what are the top performing applications, application consuming the bandwidth. Okay, all the details you can see on the dashboard. And always remember, SD-WAN is for the WAN technology. Okay, similar way you have the SD access, which talks for the LAN device point of view, where you have the graphical interface of the DNAC, and which will also show something very similar kind of graphs. Okay, which device is taking more number of bandwidth, the wireless users, lot of things in that. Okay, so in the case of SD-WAN, these are also the different protocols or the APIs that use REST conf, net conf. The syslog packets can be viewed here. It's gonna use the SNMP, the flow export. So what else than the GUI that you can use to take the control is you have the CLI and you have the Linux access. Okay, and on top of this you have GUI. So the best preferred way is GUI because they are very simple. Okay, now regarding the planes. Okay, so as we know, there are three different planes. We call it as management plane, or also orchestration plane, control plane, and data plane. Okay, so your management plane consists of the vmanage act as a heart. Vanalytic is optional. If you will see almost every log here, but if you want to add something, might be you wanna see more number of log, or you wanna see more number of reporting, etc., you can add vanalytic with vmanage. Okay, so under vmanage dashboard, over here you will see a new tab for the vanalytics. That's just a add-on package. If you buy it, you will get this tab activated. If you don't buy it, you will see all of the things within the dashboard of vmanage. Okay, under control plane you have your vsmart controller, and under data manage you have your the devices which are kept on the core layer. Okay, devices like ASR, ISR. These days we have the lot of ISR supported. Okay, like the 4K ISRs. We also have the V edge routers. We have the C edge routers. Okay, we also see variety of these devices. Okay, so these devices, so the same thing over here. In the case of orchestration plane, containers or VM, we have this vBond. So I'm going to tell you what are these controllers. So we have vmanage, vBond, vSmart, and vEdge. Okay, so vManage is the heart of the SD-WAN controller, or I can say that it belongs to the management plane. vBond belongs to orchestration plane, or I can call as the security plane as well. vSmart act as a control plane. vEdge act as a data plane. Okay, if you see here, they can be created under controller or VMs. Okay, so basically we can go either physical or we can go either virtual. So let's talk now plane by plane, okay, or controller by controller. So when I have a management plane, which I say always as heart plane, or the heart of this SD-WAN, we have vManage, okay. So this vManage graphical interface, it's gonna give us couple of benefits. We can configure policies, template, we can provision them, multi-tenant with web scale, single pane for glass D0, D1, D2 operations, troubleshooting, monitoring, software upgrades, GUI with RBAC, programmabilities interfaces like RESTconf, NestConf. Okay, so basically they are supporting APIs. So if I run the Python script, okay, I can get the complete inventory. I can get the complete device or the vEdge devices. Okay, so I can automate these things on the controller as well as. So this is the management plane. Control plane, which helps in discovery, okay, with the help of OMP protocol. It's gonna advertise control plane update between the end routers. So these are the end routers. Okay, so the control plane, which is over here, vSmart controller. So basically they will take care of the policy update. Policy update is nothing but what that particular end router has to perform. Okay, let's say 80% to WhatsApp, might be 20%. So those are the policies, right? So vSmart will push those policies to these devices, end devices. So you can see here plane policies, chain, all those things. Okay, so basically it is used to reduce the control plane complexity. Okay, now it's very easy here. How does this authentication happen? It happens over on whitelisting certificates. Okay, so via this we will have a successful relation between vSmart and these end devices. Orchestration plane, which is called as vBond. Okay, so basically vBond's work is during the starting initial setup of SD-WAN. Okay, so basically vManage, the controllers, they form they have to communicate with vBond. vBond has to authenticate that yes, you are the right vManage for me, you guys are the real vSmart. So once that has been done, then it's basically vManage who is gonna take control of the rest of the actions. Okay, the vManage is going to be heart, but the first step was vBond, so we call it as orchestration plane, and some guys you might hear calling it as a security plane because it is giving that security authentication. Okay, so it's the first point of authentication, the first whitelisting, when even the vManage was not configured. Okay, so even the vManage has to form authenticated with vBond, saying that he is the rightful vManage controller for this enterprise. it is going to it's going to distribute list of vSmart, vManage to all other guys. Okay, so basically, how are these people gonna know who is the right controller for them? Might be there's some other ROG controller which can act as the SD-WAN controllers, right? So basically, bond is gonna inform them that this is your vManage, okay, and follow order from this guy in the future. And the final is the data plane. So as we all know, data plane is your devices kept in the enterprise. Okay, so basically you have two end devices. So one belongs to Viptela and the second one belongs to Cisco. Your iOS XE supports SD-WAN, the XE family. Okay, so you have your ISR devices where you have the 4K, 4.4K, which all supports nowadays SD-WAN. By default, SD-WAN features will be not enabled when you buy this kind of XE boxes. SD-WAN feature will not be enabled. But with a single command, we can convert the normal behavior into the SD-WAN behavior. Okay, so you have to convert the mode on these boxes. Establishes secure control plane with smart. So basically with smart controller and these end devices, there will be the OMP protocol which will be used for discovery. Implement data plane and AAR policy. So you know what is application aware policies and you know what is data plane policies. Okay. Export performance statistic. So basically data plane is gonna give its performance outcome, which interface is consuming more bandwidth, what are the applications that's consuming the highest bandwidth. Okay, you also support zero touch deployment and PNP in the case of Cisco, and ZTP in the case of Viptela. So it's when you have these boxes kept on the day number 1 and you just wanna bring it inside SD-WAN for your network, right? So basically first authentication and whitelisting has to happen. Okay, so it is made very simple by these portals. You just have to log into your own registered portal and send the instruction to sync. Okay, they can be either physical boxes or they can be virtual on a hypervisors. Okay, so as I told you, this is optional. You don't have to mandatory have this. It's a optional, but if you have this, you will see a lot of analytics. Okay, so telemetry, capacities, the violations, detections, the QoE, the gradings, data, opt-in customer model. So yes, it depends on the package that you buy. Okay, so basically vAnalytics will be a part of vManage. Okay, so if you open the vManage dashboard, you can see the vAnalytics tab over here. Okay, if you don't have the package, when you click this, you will not see anything. You will see a blank page. But let's say you have also purchased the package, then you will see the logs over there. Okay, these are some of the hardware devices for the data planes. Okay, so this is how the box looks like. This is a VH boxes. I'm talking for the data plane. So these are the features these boxes are gonna support. Okay, so this is a VH100, whereas here you have VH100, you have VH1000, 2000, 5000. Okay, so the features are being once again mentioned. You can see like IPsec tunnels, inputs, the mountables, the SFP, pluggable 8 into 1G SFP. Okay, so basically it looks like your normal router and switches, but they are being specially designed for handling SD-WAN. Okay, nowadays we can also convert those XE boxes straight away to SD-WAN. Okay, so that is also possible, but these boxes are not very much compatible with the controller. So still customer prefer having the V edges, the default ones. Okay, this is the ISR boxes which I was talking about. Okay, so you can have ISR boxes and ASR boxes acting as your VH CH, which is kept in the data plane. Okay, so as I told you, the ASR, the 4K devices, 1K devices, and ASR 1K, they all can form as a data plane devices. All right, so from CCNP point of view, I think these are good things which we covered so far, and let's wind up. Okay, we have discussed the control plane, data plane elements. We have discussed traditional WAN and the SD-WAN solution that it has to offer it. Okay, so this completes the complete encore, and for NRC we did this. So that completes NRC. Okay, so that's all from my end. Let me know if you guys have any doubt. So this was your last class of this CCNP batch. Yes, there are last few classes notes which are pending on me. Okay, I have not got some time to work on those class notes and the lab. So basically I'll work on them and I'll put up on the web portal. Okay, so whenever I post something, I'll update in the group, so you guys get the notification. There are like 2 weeks of topics which were not was not being taken up, but yes, I will do that. Okay. All right, guys. So a very lengthy batch which started in the month of March and getting completed in the month of September. I hope it was really a very good batch for you guys from your career point of view. Okay. So in future, if you need any help on the CCNP or if you need any other course from me, so you can reach out to me and I'll be always there to guide you guys. Okay. So see you everyone, and good luck everyone. So let's meet up in the let's meet up in the next batch or might be in the next course. So thank you everyone. Thank you for joining this batch. I hope it was all good. Okay. And regarding the course completion certificate, I'll give you the course completion certificate. Might be next week. I'm little occupied in the weekend. So the next week I'll give you the CCNP course completion from my end. But yes, you know that certification is something which you have to get it done from the VUE Pearson, right? So you will approach the website, Pearson website, you will book your slot and you will write the exams, and that will be the official certification. Okay. So from my side, I'll give you the course completion. Might be if you're reimbursing the fees or something from your employer, you can go ahead and you can get it done. Okay. Thank you everyone once again, and see you soon. Take care. Good wishes. Okay.